let's find the absolute and local maximum and minimum values of f of x is equal to x cubed minus 6x squared plus 5 on the interval from negative 3 to 5. There are three main steps to this process. The first thing that you want to do is to find the critical numbers. Then we'll find the outputs of our function for these critical numbers, and then we'll compare the outputs. So let's start by finding the critical numbers. Whenever you're given an interval, you want to make sure that you are checking your endpoints. So your endpoints are automatically critical numbers. Although you cannot have a local maximum or minimum value on an endpoint, you can have an absolute maximum or minimum value at an endpoint. So we have two of our critical numbers. To find the other ones, we need to first take our derivative. The derivative of our function is 3x squared minus 12x plus 0. Once we have our derivative, we need to find out the x values where it's undefined, and they give us f prime of x is equal to 0. 3x squared minus 12x is never undefined. So next we'll check for where it gives us 0. I notice that 3x squared and 12x both have 3x as a factor, so I can pull that out, and I have 3x times x minus 4. Then using the zero product property, I find that x is equal to 0 or 4. And now I have all of my critical numbers. So my critical numbers are where x is equal to negative 3, 0, 4, and 5, combining my endpoints, and that x is equal to 0 and 4 from my derivative. Now that we have the critical numbers, next up, we want to find the outputs for each of these critical numbers. You want to be very careful that you're substituting back into your original function and not accidentally substituting into your derivative. We're trying to find the outputs of our function, not of our derivative. So we need to check and find f of negative 3, which will be equal to negative 3 cubed minus 6 times negative 3 squared plus 5. Negative 3 cubed gives us negative 27. Then we have negative 6 times negative 3 cubed, which would give us a minus 54 plus 5, which is all equal to negative 76, which I'll circle so it's a little easier to find later on. So we've checked x is equal to negative 3. We need to check and find 3 more outputs. We have to find f of 0, which will be equal to 0 cubed minus 6 times 0 squared plus 5, which gives us 5. We need to find f of 4, which will be equal to 4 cubed minus 6 times 4 squared plus 5, which is equal to 64 minus 6 times 16 gives us 96 plus 5. 64 minus 96 plus 5 is negative 27. Then we have to find f of 5, which is 5 cubed minus 6 times 5 squared plus 5, which gives us 125 minus 150 plus 5, which is equal to negative 20. So now we've found the outputs at each of our critical numbers. Next up, we want to compare these. We want to be careful. Our endpoints are f of negative 3 and f of 5, which means that they cannot be the locations of local maximums or minimums. Okay. Sometimes I find it useful to sketch a quick picture of a graph to help me out. So let's see. My x values range from -3 to +5. And my y values, the highest y value I hit is 5. And I go all the way down to -76. So I'll count by 5s real quick. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. And that's pretty much what I need there. So f of -3 is -76. So that's my -3, -76. F of 0 is 5. F of 4 is -27. So 5, 10, 15, 20, 25, roughly 27. And f of 5 is 20. So that means that our function is doing something vaguely like this. If it were a different function, so something that wasn't a polynomial, we might have to find some other information. But since this is a polynomial, we know that it will roughly connect like this. Okay, so let's see. Let's start by finding our absolute maximum. Our absolute maximum is right up here at f of 0 is equal to 5. Now let's find our absolute minimum. The very lowest number that we will reach. So the lowest our function goes is that -76. So our absolute minimum is f of -3 is equal to -76. Then we'll check for any local maximums or minimums. We have a local maximum at x is equal to 0. I suppose we could say f of 0 is equal to 5 again. So at x is equal to 0, we have both an absolute and a local maximum. Next, let's find our local minimum. Our local minimum is right here at f of 4 is equal to -27. Since 5 is one of our endpoints, this is not a local maximum. These are all the extreme values that we have for that function over that interval.